We're asked to evaluate the triplet integral over the region E, where E is the solid tetrahedron with the given vertices. We have a point at the origin, a point on the x-axis, a point on the y-axis, and a point on the z-axis. Let's first look at the region E in space. So the region of integration is this tetrahedron here. Notice how it's bounded by the three coordinate planes, and this green plane here, where this point would be the x-intercept, this point would be the y-intercept, and this point would be the z-intercept. So our first step is going to be to find the equation of this plane here, given that we know the three intercepts. Once we find the equations of the planes that bound the tetrahedron, this will help us determine the limits of integration. And because we have the intercepts, we can write the equation of the plane in this form here, where our equation would be x divided by 5 plus y divided by 3 plus z divided by 2 equals 1. Let's go ahead and clear the fractions from this equation by multiplying through by the least common denominator, which would be 30. So multiply everything by 30. And simplifying, here we'd have 6x plus 10y plus 15z equals 30. So now we know that the region of integration, E, is bounded by the three coordinate planes, which are x equals 0, y equals 0, and z equals 0, and this plane here, 6x plus 10y plus 15z equals 30. And now we'll use these equations to determine the limits of integration. So we have the triple integral. Notice how the integrand function is just z, and now for differential v, we can have 6 possible orders of integration, but because the integrand function is z, let's integrate with respect to z last. Let's use the order of integration dy, dx, dz. We don't have to, but it might make things a little bit easier to integrate with respect to z last. So now we need to find the limits of integration with respect to y. We'll notice how y is going to be bounded by y equals 0 in this plane here, which means we'll have to solve this equation here for y so we can express y as a function of x and z. So if we want to solve this equation here for y, we would subtract 6x on both sides, as well as subtract 15z on both sides. So that would give us 10y equals 30 minus 6x minus 15z, and we divide by 10. Simplify, we have y equals, here we have 3 minus 3/5 x minus 3/2 z, which means the limits of integration for y are going to be from 0 to 3 minus 3/5 x minus 3/2 z. And now we need to find the limits of integration with respect to x and then z, which means it's going to be helpful to find the xz trace. To find the xz trace, we set y equal to 0. So for the xz trace, we're looking for the region bounded by x equals 0, z equals 0, and now looking at the equation of the plane, again, if we set y equal to 0, we'd have the equation 6x plus 15z equals 30, which does simplify because there's a common factor of 3. If you divide everything by 3, we would have 2x plus 5z equals 10, which means the xz trace is going to be the region bounded by x equals 0, z equals 0, and the equation 2x plus 5z equals 10. And I've already graphed the xz trace here, where this would be the x-axis, and this would be the z-axis. So this triangular region here is bounded by the equations where this horizontal line is z equals 0, this vertical line is x equals 0, and this slanted line here would be 2x plus 5z equals 10. Notice how this side of the triangle has a x-intercept of positive 5 and a z-intercept of positive 2. So we can use this triangular region here to determine the limits of integration for x and z. So looking at the limits of integration for x, this area is bounded by this vertical line x equals 0. So 0 is a lower limit of integration for x. And the upper limit of integration for x is going to be this line here, which we have to solve for x. So we'll subtract 5z and then divide by 2. So solving for x, we would have 2x equals 10 minus 5z. Dividing everything by 2, we get x equals 5 minus 5 halves z, which is the upper limit of integration for x. And then for the limits of integration for z, we'll just have constants. Z is from z equals 0 to this point here where z equals 2. So this is the first part of the question. We now have one possible order of integration as well as the corresponding limits of integration. Notice how here on the right I did include the xy trace as well as the yz trace, just in case we had selected a different order of integration. In the next video, we'll evaluate this triple integral. I hope you found this first part helpful.